All right, guys, welcome back. Week 6, and this week I'm going to be discussing nuclear bombs. Now, FYI, there's no experiment that I actually did this week, just because it's super hard to do a nuclear bomb at home, obviously. So let's get into the explanation of nuclear bombs. Okay, so just a little backstory on nuclear bombs. There are two different reactions that occur within nuclear bombs. It's either fusion or fission or both. Okay, so this first part right here, this is fusion, and over here is fission. So in fusion, the main concept is the 2-to-1 concept here that I wrote down here, okay? You're going to have two elements, and they're going to combine together here, and it's going to create one element here. But it's also going to release energy and a neutron. So again, it has two elements. They combine it together to create one, releases energy, and it releases a neutron, okay? Now, over here in fission, it's going to be the opposite of fusion, where you're going to have that 1 to 2 rule, okay? So you're going to have one element and you're going to split it into two, okay? So how do you do this? We have a neutron, right? And a neutron is going to hit a very unstable element, usually uranium, okay? And this unstable uranium isotope is going to split into two other elements, okay? But while it also splits, it's also going to release 3 neutrons, okay? And it's also, by releasing those neutrons, going to release a lot of energy, okay? And that energy that I'm talking about for both reactions, that's what's going to create that nuclear reaction that we see in those nuclear bombs. Okay, so let's get into the types of nuclear bombs. So we have two different types, the atomic bomb here and the hydrogen bomb, okay? For the atomic bomb, it's only going to use a fission reaction, and it is overall less powerful in comparison to the hydrogen bomb, and I'll get into that reasoning in a little bit. And in the atomic bomb, we're only going to be using uranium and plutonium, but there's only two specific types of isotopes that we're going to be using for uranium and plutonium. For uranium, it's uranium-235, that specific isotope, and for the plutonium, it's 239. Okay. Now in the hydrogen bomb, you're going to be using both fusion and fission. So like I said, an atomic bomb only uses fission, but hydrogen bomb uses both reactions. And because it uses both, that is the reason why it is more powerful in comparison to the atomic bomb, okay? Now, the hydrogen bomb also uses uranium, plutonium, and lithium deuteride, which is a type of fusion fuel, and I'll get into that in just a little bit when I explain the hydrogen bombs a little bit more. But deuteride specifically is just a type of hydrogen isotope that you can see here. Just put a diagram just to make it easier for you to understand that a little bit more. But yeah, awesome. Okay, so let's get into a little bit more specifics. Okay, so here is the atomic bomb, okay? There's, I guess you can say, two different types of atomic bombs. And I'm going to use both uranium and plutonium to describe both. But for atomic bombs in general, the thing you want to reach is critical mass, and that is the minimum amount of an element needed to create the nuclear reaction that you want in this bomb, okay? So in this first little diagram here with the uranium, like I said, we're going to be using uranium-235, as you can see right here, okay? So what's happening in this one is there's two non-critical mass sections of uranium-235. Those are going to connect together and create that critical mass of uranium-235 by this chemical explosion that's going to happen over here. So this explosion is going to occur right over here, and it's going to cause this uranium-235 part to hit this other uranium-235 part, and it's going to create that critical mass that we want. Okay, now when that critical mass occurs, that is going to create that fission explosion and reaction and release those 3 neutrons, or more, obviously, because you need more than just 3 neutrons to create a big nuclear reaction, but it's going to create that huge fission reaction and that bomb explosion that we all know and seen. Okay, now in the plutonium implosion design over here, we have plutonium right in the middle. Remember, it's plutonium-239, that specific isotope. That's going to be in the middle here. And then surrounding it are they going to be these chemical explosives. Now, when these detonate, this is going to create kind of an enclosure on into towards the plutonium. Okay, so the space around the plutonium is going to start to close in, which is going to cause the density to increase of the plutonium, and it's also going to create a really tight space. So with the increasing of the density and this tight space, right, this is going to increase the chances of a neutron hitting the plutonium and the plutonium and causing that split of the plutonium into 2 other elements. Remember, it's a 1 to 2 fission reaction. It's going to split the plutonium and release the energy in those neutrons and cause that fission reaction that we know of, the atomic bomb. Okay, so that is how the atomic bomb works with the fission reactions. Okay, now let's get into the hydrogen bombs. So in the hydrogen bomb, like I said, it uses both fission and fusion. Now it's going to use 2 fission reactions and 1 fusion reaction, but specifically in a fission to fission reaction. That is how you're going to see in this diagram, okay? So over here is the primary. This is the primary, and this is the secondary reaction. So this is the fission and fusion, and there's going to be another fission reaction right over here. But this is primary and secondary, okay? In the primary, that's where the first fission reaction occurs. Now, when the first fission reaction occurs, it's going to release X-rays that we see here, okay? Now, these X-rays are going to hit the casing of the bomb, right? And it's going to cause the foam around the secondary to heat up, okay? And it's also going to ignite this spark plug in the middle of the secondary. Now, this, it can be a couple things, but we're going to say it's plutonium in this. So the plutonium is the spark plug, okay? So the X-rays are heating up the foam around the secondary, and it's also going to start to heat up this spark plug, and it's going to ignite it, okay? Now, around the secondary here, there's some pressure. As we can see, there's pressure, and heat. And then because the plutonium, the spark plug, is ignited, it's also going to cause pressure inside the secondary. So there's pressure outside and inside the secondary with the heat. Now this is the perfect combination for fusion reaction, okay? And as we know, there's like some fusion fuel, which I remember said it's the lithium deuteride that can be a form of fusion fuel. This is going to cause it, all this pressure and this heat is going to cause it to ignite right here, as we can see here, okay? All this is igniting. Now remember, at the end of fusion reaction, it releases a neutron. And this neutron from the fusion reaction can hit the uranium tamper here that we have, that we can see, okay? Because it can hit that uranium tamper and uranium is unstable, it might split that uranium into 2 other elements and cause another fission reaction to occur, and thus even more energy and more neutrons to release in that really big explosion that we know that hydrogen bombs can do. So shows another reason why the hydrogen bomb is more powerful in comparison to the atomic bomb, because it has kind of 3 reactions happening, 2 fissions and 2 fusion and 1 fusion reaction. But there you go, guys. There is the nuclear bombs, both atomic and hydrogen. Hope you learned something. I learned a lot. It's pretty cool, and it's really cool to understand it more. But thanks, guys, and see you next week.